Hello everyone, welcome to Rakesh VALASA YouTube channel. In this video lecture, we will discussing about one of the important problem in strength of materials for GATE exam. Already this question came in GATE 2023. Let us see the question. A cylindrical transmission shaft of length 1.5 meters and diameter 100 mm is made of a linear elastic material with a shear modulus of 80 gigapascal. While operating at 500 rpm, the angle of twist across its length is found to be 0.5 degrees. The power transmitted by the shaft at the speed is kilowatts. Here, first write the given data. Read the question twice and write the given data. See here, uh, a cylindrical transmission shaft of length 1.5 meters. Here, given that length is 1.5 meters, L equal to 1.5 meters and convert into millimeters, that is 1 meter equal to 1000 millimeters, so 1500 mm is made of a linear elastic material with a shear modulus. Here shear modulus or modulus of rigidity both are same, that means G equal to 80 gigapascal. To convert into Newton per mm square. Giga means 10 power 9. So you can write 80 into 10 power 3 megapascal. Here 1 megapascal equal to 1 Newton per mm square. So you can write 80 into 10 power 3 Newton per mm square. While operating at 500 rpm. RPM means that is speed. N equal to 500 rpm. The angle of twist across its length is found to be 0.5 degrees. So theta is given that is 0.5 degrees. To convert into radians, that is 0.5 into 5 by 180 radians. He is asking that the power transmitted by the shaft at this speed. So he is asking that P. Once you can see this question, he has given a length, shear modulus, speed, theta. Uh, from these notations, you can write torsion equations. These all notations are available in torsion equation. So he has given that cylindrical shaft. So by using torsion equation, we can find out torque. Then by using this torque, we can also find out power. P equal 2 pi nt by 60. Let us see. First write torsion equation. Torsion equation. Okay, we know that formula, that is T by J equal to G theta by L. G theta by L equal to tau by R, where T means torque or twisting moment. T means torque or twisting moment. Twisting moment. Here J means polar moment of inertia. Polar moment of inertia. For solid shaft, we know that formula pi by 32 d power 4. Pi by 32 d power 4. In the given problem, diameter is also given, that is 100 mm. You can write here d equal to 100 mm. Next, G means modulus of rigidity or shear modulus. Modulus of rigidity. Uh, Theta means angle of twist. L means length of the shaft. And tau means shear stress. Finally, R means radius of the shaft. Radius of the shaft. Okay. Okay, this is regarding torsion equation. From this equation, uh, we need to find out. Actually, we know the formula for power, that is P equal to 2 pi nt by 60. See here, P equal to 2 pi nt by 60. Here, T is unknown. By using torsion equation, we need to find out T. From torsion equation, T equal to uh, jg theta by L. Okay, right here. From torsion equation, you can write here uh, T by J equal to g theta by L. Take first two terms. From this equation, you can find out torque T equal to g j theta by L. Here G means shear modulus, that is it into 10 power 3 into polar moment of inertia for solid shaft pi by 32 into d power 4. D means 100 mm. Next, theta means angle of twist, that is 0.5 degrees into pi by 180 to convert into radians by length. Length is 1500. Okay, by using calci, we can solve this equation. All okay. Now open calci. Okay, take division it into 10 power 3. Next into pi by 32. Pi by 32 into 100 power 4 into 0.5 into pi by 180 by 1500. Now click equal to. Okay, this value is okay 45692 261.297 Newton millimeter. Now write the answer. This equal to 4569261.297 Newton mm. Now convert into meters. So 1 meter equal to 1000 mm. So you can move this decimal point to before 2. 4569.261 Newton meter. Uh, Here he is asking that power transmitted by the shaft at this speed. So P equal to 2 pi Nt by 60. So 2 pi, speed is 500 rpm, torque is 4569.261 by 60. Okay, by using calc you can find out this value. Now open calc. Okay, clear this one. Take divisor. 2 pi shift pi into 500 into 4569.261 by 60. Now click on equal. That value is 239245.94. that is watts. He is asking that in kilowatts. Okay, right here. Two three 9245.94 watts. He is asking that power in kilowatts, so you can move decimal to 3 digits before 3 digits. 239.246 kilowatts, but he is asking that only round off to 2 decimal points, so the answer is 239.25 kilowatts is the final answer. Okay, this is the most important problem in strength of material for any competitive exam. Here torsion equation and power equation are very important. Okay, thank you for watching. Please do like and subscribe my channel for more updates.